Hello student, today I will start the topic cleavage. The pattern of cleavage is determined by the amount of distribution of yolk in the egg. The amount of yolk present is moderate and is localized in the vegetal pole, that is the ovum is moderately trilolicital or mesolicital. Yolk is always an obstruction. Yolk is always an obstruction in the mitotic divisions, which indeed constitute cleavage. The cleavage is holoblastic and unequal. Cleavage is holoblastic and unequal. First cleavage is meridional or vertical and bisects the egg into two identical blastomeres. Its cleavage furrow appears at the animal pole about 2.5 hours after fertilization. After about 3 hours, the egg is completely divided into two blastomeres. The plane of first cleavage furrow is determined by the direction of approach of sperm nucleus and includes the population path. Second is the second cleavage begins at the animal pole in about 3.5 hours after fertilization, and before the first cleavage is completed, the second cleavage is also meridional but at right angles to the first. It produces 4 equal sized blastomeres. The third cleavage begins after 4 hours of fertilization. The cleavage rate is accelerated with each division. It is latitudinal, horizontal, and at right angles to the both the first and second cleavage. The cleavage furrows passes through the egg well above the equator in the animal hemisphere and produces 8 blastomeres. The upper 4 blastomeres are black and small, called macro or mid. The lower 4 are large and full of yolk, called macro or megameres. The fourth cleavage is meridional and at right angles to the third, but there are 2 simultaneous divisions which are at right angles to each other, and as a result 16 cells are formed. The fifth cleavage is also double and horizontal and cuts all 16 blastomeres into 32. It produces 4 tiers of blastomeres, 2 upper tiers of 8 micromeres, each in the animal hemisphere, and 2 tiers of 8 macromeres, each in the vegetal hemisphere. In Rana, after the fifth cleavage in Rana. Rana is the frog. Rana tigrina. After the fifth cleavage, the division highly irregular. The fifth cleavage, the division highly irregular and cannot be followed with any. However, in Frog xenopus, it has been observed that 11 subsequent cleavages take place synchronously every 35 minutes. However, after the 12th cleavage, or when embryo blastula contains about 4096 cells, the cell cycle becomes longer and asynchronous. The cells become motile and RNA synthesis, transcription starts. New Sports and Kirchner in 1982. This turning point is development is called mid-blastula transition. Gerhardt 1980. The process of gastrulation starts when there are about 20,000 cells. Smith 1988. Blastulation at the 8 cell stage. Rook 1950. A small fluid filled space called the blastocele or segmentation cavity appears between the blastomeres in the animal hemisphere due to the called the blastocele or segmentation cavity appears between the blastomeres in the animal hemisphere due to the rounding off of the blastomeres. The blastocele increases in size as the cleavage progresses. The albuminous fluid in the blastocele is secreted by the surrounding blastomeres and contains mucopolysaccharides. As the cleavage progresses, the adhesion of the blastomeres to each other increases and they become arranged to form a true epithelium called blastoderm. In the fully developed blastula, the blastoderm remains 2 cell thick towards the animal pole of the egg and forms dome-shaped roof of the blastocele. The sides and flower of the blastocele are formed by multi-layered blastoderm of large yolky macromeres and the roof by the pigmented micromeres. The embryo containing the fluid-filled blastocele and the blastoderm is called the blastula. Heat maps of the blastula of frog. In the blastula, the blastomeres, which have to form different germinal layers and different organs of the adult frog, have their representation at the external surface of the blastula. The head of each type of blastomeres has been observed by artificial vital staining method of worked in 1925, and prospective organ regions maps or late maps have been prepared for the blastula of frog. According to the fate map studied, the whole surface of the blastula of frog can be divided into these following three areas: presumptive ectoderm area, prospective notochord and mesoderm area, and prospective endodermal area. Okay, thank you.